welcome to this week's technical webinar. Very excited today to have Helena Edelson presenting on streaming big data analytics with Team Apache. That is Apache Spark, Spark Streaming, Apache Kafka, and Apache Cassandra. So just a little bit about Helena. So Helena is a well-known committer on several open source projects. She's an expert in Scala and Akka. She has been working at DataStax now for, I guess time flies, Helena, but it's what, 9 months, 8 months on Spark and Cassandra. So delighted to have Helena present today. Spark is a very, very hot topic. So one note about Q&A. So Helena has a very packed content agenda today. So if you would like to ask a question, please use the Q&A tab inside of WebEx and type your question in there. If we can get to questions at the end, we absolutely will, and Helena will answer just as many as we have time for. But if we cannot get through them all, then Helena is actually going to take the question log and write a blog post that answers most of the pressing questions. And that blog post will be available on the DataStax developer blog. So without further ado, we will pass the ball to Helena. And Helena, thank you very much indeed for presenting today. Over to you.
Okay, welcome everyone. Can you all hear me?
Hearing you great, loud and clear, Helena.
Okay, great. Just a few things. I do have a lot of information to cover, so everyone's questions will be answered. I'm going to do a follow-up blog. You can also shoot me questions on Twitter. On this slide at the bottom, you can see my Twitter username, and I'll include everything in the follow-up blog post. We also have a mailing list for the Cassandra connector, so any questions can be asked on that. And at the very end of the talk, I'll be showing a slide with a bunch of resources and links that you can all look at, including the slide share where I'll be posting these slides to at the end. And I do believe that this whole session will be recorded. Okay, so these are the high-level topics that I'm going to be getting into. The thing to understand about everything that I'm covering is, I mean, we could literally spend 3 weeks covering all of this. Even just with Spark and Spark Streaming, we could easily cover a week of, 9 to 5 training. So some of the topics I am going to have to brush over, but I hope that I'm going to give everyone enough to walk away and, have URLs to hit where they can see really good samples and even download GitHub repos so that they can start running some code right away. So what this talk is really going to be about, though, is primarily we're going to be getting into API integration. I am going to be covering a short intro to Spark and Spark Streaming, but I wanted to do a high level of why we're pairing these technologies in the first place. And I do have a starter slide. I use this in conference talks, but we already talked about who I am, so I'm going to breeze past it. Just quickly, I wanted to start with these 2 slides just to sort of give a perspective quickly of where I was coming from when I started to look at Spark, because I do get a lot of questions from people when I've given talks at meetups, for example, wondering about use cases and why would you be wanting to switch, for example, from batch to streaming, going from something like using Hadoop and scalding or Hadoop and cascading to Spark in the first place. So this is an example of using Hadoop with scalding, and scalding is an excellent API working with Scala that runs over Hadoop. A lot less code, because one thing I'll get into with you guys in this talk is they abstract a lot in their APIs. You can do complex analytics with very minimal code, which also means that your code is going to end up being far less buggy, less to maintain, which is in the end very important. There are a few deployment options using Spark, currently just 3. You can do it as a standalone, like when you're using it with Cassandra, for example, or you can deploy it on Apache Mesos or Hadoop Yarn. It does come with some EC2 scripts for launching, and it works out of the box on EMR. They do document all of this very well on their site if you need to dig into this further. Okay. Okay. So jumping into the basic Spark API, the common abstraction that we deal with when working with Spark is called the RDD, which is a resilient distributed data set. The thing to understand about RDDs is they're a collection of objects spread across the Spark cluster. And as I mentioned briefly before, they're stored in RAM or on disk, depending on how you configure it. And all of the operations are run in parallel. They are built, everything's built to parallel transformations. You can configure the persistence that you want to indicate basically which RDDs to reuse and their storage strategy. They are partitioned, so you can indicate which RDD elements to partition across machines based on a key in each record. And everything is highly typed with implicit conversions on any RDD. And I'll show you some of that in the code samples that we're going to walk through. And this is just a quick slide on the Spark data model, but they're immutable, iterable, serializable, parallel, and everything is executed in a lazy fashion. So back to our Spark word count, our very basic sample, just to show you everything's broken out into 2 basic types. There's Spark transformations, and then there's Spark actions. And so that flat map and map on line 19 and 20, and then reduced by key, those are examples of transformations. And then the collect function on line 22 is an example of the action. One thing you notice right away when you look at the Spark API is that the transformations are very similar to a Scala collections API. So for any Scala users, it's pretty much innate to you out of the box. It's very easy to use. Each of these transformations are going to produce new RDDs. Everything, as I said, is a lazy compute, so transformed RDD gets recomputed when an action is run on it. You'll see through the slide deck that we're going to show things using filter, flat map, distinct, group by, union, step, reduced by key, all of the standard functions that you would expect for an API like this. And then some of the actions require materialization of the records in order to generate the values. And so some of those might be collect or count, fold or reduce to get the data out of that and do something else with it. If you're in the REPL, for those of you familiar with a REPL, for example, Scala comes with that. One of the reasons that they chose to go with building Spark in Scala was to take advantage of a REPL. So this sample sort of shows you what the typing out of the box is. That if I create any kind of collection, this data collection, the array 1, 2, 3, 4, 5, that basically is going to give me a Scala array of ints. And then when I call SC, when you're using the Spark REPL, it automatically gives you a Spark context that's represented by that SC. So with the Spark context, and you can configure that with the REPL too, but just out of the box it does expose that for you. You can call sc.parallelize, and into that parallelize function you can pass in any kind of iterable data type. So we pass in our data array, any collection, and that's going to give us, that creates the Spark RDD of ints. And note that I didn't have to specify any kind of type parameters on that parallelize function. It just out of the box will convert it to the right type based on the data that you're passing in. So I wanted to show you just a basic word count, what you're setting up there. This is going to be the Spark conf, the first thing that you do. Here in the set master function, I'm just passing in local. And this is one really nice thing that you can do with Spark. You can automatically just really quickly start to prototype things and play with the API without having to, get into deploying a Spark cluster. You can just run things in a standard app locally. So you can set the master as local star. And then I'm going to set the app name, whatever your app name is, excuse me. I create a new Spark context, and then now we have the Spark context reference. I can call a text file, so I'm going to pass in just, I have a sample text file of words. And then I can call flat map. I'm going to split every entry in that file into separate words, and then for each word in the map function, I'm going to flatten everything, add the one, and then in that reduce by key function, I'm going to be doing the word count. There's several ways you can do this, and I think I show a few of them in the sample code slides. And then I call collect, and I'm just going to print it out. So that's really, really sort of the 101 example. This sort of gets into some other things that you can start to do, just showing you right now the really how easy it is to use the standard API. So here I want to return the top K, some like top 20 highest temperatures for any location in a given year. So if I have a class and I'm going to pass in some aggregate of data, say that aggregate represents maybe like 360 or something sequences of temperatures that are doubles. So that's what that aggregation represents. I pass that into the Spark context.parallelize function, and then I can just call top K. I don't have to do anything else. Spark is going to abstract that away from me, and I just pass in how many at the top that I want it to do. So that's just a really simple example of the abstractions. It's pretty amazing how many higher level functions that they provide for you, so that it really nicely bridges the gap for data scientists to do any kind of development that they need for their work, and also for developers to bridge some of the data science gap that they don't know about, but they can implement things very nicely. Oh, also I wanted to just show you this collect async down at the very bottom. I'm doing the same parallelize function top K call, but I'm calling collect async, so that's going to give me in the future a feature so that I don't have to block the caller thread. And just quickly looking at the API for one quick slide, it's just to show you what some of the basic Spark functions are. This is all just part of the basic API. Some of the Spark components, now this slide particularly shows some of the more alpha parts of Spark, like Spark R. I think they have one more, but I didn't have it on this particular slide, but there's the Spark engine, the basic Spark core API, and then on top of that there are external modules. Well, these aren't the external, but Spark SQL functionality that you can add on if you want to use that. Spark streaming is a separate API that I'm going to go into quite a bit. I think I just have maybe 1 or 2 slides on Spark SQL. The Spark ML Live for machine learning, which is really, really nice. And then the GraphX and Spark R. I haven't used the Spark R yet, but those are alpha. And I've got a lot of questions on why they chose to do it in Scala, and there was a really interesting post, there's the URL for it, where Matej described why. But some of the reasons in a nutshell are because Scala is functional. It's a very clean API to use. It runs on the JVM, which in my understanding, they wanted it to be very easy for the Hadoop community to be able to start to use Spark. And, Hadoop is written in Java. Also, the core functions they can ship them across the network, and that's a really important functionality, why they chose using Scala. And the static typing, it's easier to control performance. And as I said before, being able to leverage the REPL is really nice. When batch is not enough, okay, those 2 slides I showed you guys in the beginning, basically I just wanted to show you some use cases that you might start to think about when you wanted to move from batch to something like Spark Streaming to be able to use Spark in event-driven applications. Like I want to run computations in my Akka, for example, event-driven asynchronous application. That might be one major use case that you would want to move away from just using Hadoop or using basic Spark and starting to use Spark Streaming. So Spark Streaming is an extension of the core Spark API. It allows you to access high throughput and reliable processing of your live data streams and leverage sophisticated algorithms as high-level functions to process those data streams. And I think one of the more important features of Spark Streaming is it's exactly once message guarantees. I've been asked about this particular thing a lot. In contrast, Storm provides exactly once processing, but the thing to note there is that it's only in conjunction with the Trident add-on as far as I know, and I've heard that that's not a trivial thing to set up. I haven't personally set that up. Okay, so this slide is just showing, I think it shows all of them. There might be one or two left out, but some of the Spark Streaming input and output sources that you can very easily integrate with. This is a huge difference, too, from single-threaded procedural data analysis that you might have done in the past, doing computation over the past decade or earlier. Now we can do all this with Spark Streaming. So just basically trying to see from a very, very high level what this would look like is you have your input data stream, goes through Spark Streaming, which does basically micro batches, runs through the Spark engine across the Spark cluster with everything parallelized, and batches the process data out. And you can plug everything in on the input side and the output side very, very easily. Some of the common use cases, too, because I've been asked this quite a lot, when would I even want to be using Spark Streaming? So, for example, things like real-time adaptive analysis, or things like statistics and response, when you are using or working with sensors, alarms, or a cluster, or, say, a fleet management, definitely for things like security and finance, telemetry, or diagnostics. And also, you can use it for things like with the Internet of Things, online ads, conversions, supply chain, and campaigns. So this makes everything much more powerful, so you can easily adapt Spark ML Lab with all of this, too, from machine learning pipelines to those streaming data pathways. Unfortunately, I don't think for this presentation I include any ML Lab integration, but it's really, really nice. So stepping in now to what Spark Streaming does, this is the basic concept under Spark Streaming is the D stream, the discretized stream. It's essentially a continuous series of RDDs, and each of those RDDs represent a window of time or an interval, like from N1 to N2. And this is something that you configure depending on the particular data and collection that you want to do. So the data is received during each interval. It's stored across the Spark cluster to form an input data set that we refer to as a microbatch for that interval. And then once the interval completes, this data set is processed with parallel operations like the ones we kind of walked through already, the map, reduce, join, and window, for example. And these can be stored and used to produce new data sets for further transformation. So building upon the D streams are things like the input D stream and receivers. So the D streams, there are two basic types. There's basic and advanced. And the basic types are included in the core Spark Streaming API. And those are things that you can use out of the box, like with file systems, streaming from socket connections, and also streaming your Spark data and computations through Akka actors. All of that comes out of the box with Spark Streaming. And then in the external module, which are separate artifacts from Spark, You can also integrate with other input streams and receivers like for Kafka, Loom, Twitter, Zoom, Q, Kinesis, and some other ones. And just a quick note about receiver reliability. There's kind of two different types if you want to think about it that way, because some receivers, for example, like when you're working with something like Kafka, do support acknowledgments or acts. And so when it's done correctly, I have to underline that word, and reliably, those can be considered reliable receivers. And then unreliable receivers you might consider to be just sort of APIs that don't support acts, but also note that they could be not properly implemented, depending on who implements it. So you just have to be aware of that. Reliable receivers, unreliable receivers, but primarily it's just when they don't support acts in those APIs. And this is a list. I think it's current, but of course the versions are 1.2.0 right now, not 1.1.0. But of the external, in the external module for Spark streaming, and these are available in the Spark repo for separate artifacts that you can integrate. And we're going to walk through, for example, using Kafka, and I think I have one slide for Spark streaming Twitter for you as well. Okay, this is, I think I covered some of this, but for Spark streaming, the basic constructs that you want to set up before you start getting into the actual logic is you create your Spark conf. Here with Spark streaming, there are a few extra things you're going to be adding. This only shows you some of the things, and the serializer is not specific to Spark streaming, but it just is from a code sample that I had for Spark streaming. And I also included it just to show you it's very easy to set up a serializer or any kind of custom serializer. For example, I think by default it uses Cryo, but you do want to plug in your custom registrator class. And then I create my streaming context, and I'm going to pass it. There's several different ways that you can create the object. Here's a really simple one, though. I'm just passing in the Spark conf, and I'm configuring my batch interval. Now, the batch duration, just as a side note, that's the time interval which streaming data will be divided into batches. So that's how you do that. And there's some kind of algorithm for it. It really depends, but also it primarily depends on what your data is and how often you want to select it, batch it. Sorry. So we start the Spark streaming context. By the time that you start the context, that second line from the bottom, you do currently, anyway, need to make sure that all of your streaming outputs are defined. I think that in the future they're going to make that more flexible. And then once I've done that, I can call await termination. And that's a function you only really use with Spark streaming. So you've deployed your Spark streaming application to the Spark cluster. It does all the setup, and everything's lazily evaluated, of course, in all your streaming definitions. So it just starts it up, and say I'm hooked onto a Kafka topic or something. It's not going to start actually computing the data from a particular topic until the data starts streaming in. And in the sample I did, on that third line from the bottom, mention streaming context at checkpoint. And that's a pretty important concept to understand. It's hard to talk about in one slide, but from a very, very high level point, streaming applications basically need to be at 24/7. So they therefore have to be fault tolerant to failures outside of the application logic, like network failures or JVM crashes. There's two basic types of data that Spark streaming is going to be checkpointing. Some of the data, well, one of them is metadata. It's just used to recover data from any kind of node failure, and the node failure specifically on a node that the Spark driver is running on. So effectively, that's your Spark application node. And the type of things that are included in that metadata would be things like configuration, the defined dstream operations that you have in your application, and any queued but incomplete batches. So it's going to be tracking what's actually completed and what hasn't, so that for node failures it can start up. And that's actually a whole fault tolerance story that Spark Streaming has with regard to lineage, and we don't have time to get into that here. And the second kind is the actual data, so it will be checkpointing some intermediate RDDs for example, stateful transformations that you might be using. So those can be periodically checkpoint for failure. And when you would want to enable checkpointing, note that you don't have to use checkpointing with Spark Streaming, but there are two conditions you can consider that would require it. One, if you're using the update state by key or the reduce by key in Windows, those are stateful transformation functions in the streaming API, and those do require that you set checkpointing. And the other case would be if you have a requirement to be able to recover from failures. Some applications might not be mission critical, and they might not need to incur any kind of performance from that, so it's fine for them to be using checkpointing. There are possible performance hits when you're using that, but it really depends on the data or the batch sizes and the speed of processing on the file system. So there's a lot of tuning that you can do there. I wouldn't really call it a downside. It really just takes some tuning. It is something to be aware of. So a basic example for doing Spark streaming on one of the basic sources, like a file stream. So this is a file input stream. We're just taking the Spark streaming context, calling text file stream, and here I can pass in. There's also a file stream function, but here I can pass in, an S3 bucket. Right now I can't call like raw data bucket / sub partitions in there. It only supports right at the bucket level. But here I can be, it's basically going to read data from those files as they come in. So what Spark Streaming is doing behind the scenes, it's monitoring the S3 directory that you give it and processing any of the files created in that directory as they come in. And one of the nice things to consider too, for file streams, they don't require running a specific receiver, like for example, for Kafka streaming, so you don't have to allocate separate cores for that. And stepping into the flat map and the count by value, that all of those transformations are for each of those returning new RDDs in that D stream. And here at the end, I'm calling save as object files, and what that's doing, just to show you another option, that's saving each of the RDDs in that D stream as a sequence file, a serialized object. So built upon that, then, in the input D streams, we have receiver input D streams. So here's a very simple Kafka example for integrating Kafka with Spark streaming. So we call Kafka utils create stream, and so we have a key value, that's the string, and typically it probably is not going to be a string, it's going to be some kind of custom type of yours. And then they have out of the box a string decoder for the key value decoding of those. But you can also very easily extend that to create a custom decoder, and there's a few other types of decoders that you can use from that as well. And into that create stream function, there's several different ways to create that, but here I'm just passing in the streaming context, my particular Kafka params. You can pass in one or many different Kafka topics. Specifying the storage level, this is something that you're always going to be doing. So here I have disk only, but there's, I think, at least 5 different settings that you can specify for that. What I'm doing is stripping out the key from the key value, taking each of the lines of data and splitting it, and then through that final map functions, I have, raw weather data as my custom take class, and I have a apply function for that, and that's going to, in that map, just put all the data we're reading in and create that as a raw weather data. So that is creating my stream when I say val stream. Now this is all something that I would have, for example, in a single actor or in one of your classes. You can either do work in the stream all in one contiguous function and output to something right there, but here what I want to do is we use that stream. So as data hits our particular Kafka topics, we're going to be converting all that data to our raw weather data type. And then I want to do two things. I'm forking off. And with the stream, what I want to do is immediately, this is starting to show you how easy it is to use the Spark Cassandra connector, which I'm getting into next. So I immediately want to save off my raw data to a specific Cassandra key space and table. And what that's for is so that later on or at any time I need to, other processes can come along, read that data from Cassandra and do any further processing with it. So I just immediately save that off. Then I want to start doing specific information to aggregate that data in different ways. So one example here, I'm trying to, in a very easy sample, aggregate daily precipitation and then save that to my daily rollup, the daily precipitation table in my key space. And so that just shows you one very easy way to save some data and do another aggregate from that same Kafka stream. And then we do our start and await termination. And here I'm choosing not to do any checkpointing. There's a lot that I could show you with streaming window operations, but I really only wanted to, given the scope of this, just show you one quick slide. But because I've showed you several different word count variations, here I'm just saying this paired stream, imagine that's already our word count, split out key value with the count, and I want to pipe that into a splat max function, case KV. So I'm going to map that into getting my word count, and then I can do a reduce by key and window. And here I'm setting the time sequence that I want to work with for that window operation. So that's basically going to, for example, say, reduce the last 30 seconds of data every 10 seconds or something like that. You can, or you basically want to remember that the bigger the window that you're using, the more data needs to be processed in each of your batch intervals. And sometimes that's not always obvious. So for a subset of window operations like reduce by key and window, which is a common one, that's inverse function. So the amount of data processed is as small as the computation done incrementally there. These are just some of the more common streaming window operations that you can use that are built into the streaming API. I don't know if I got into this yet or skipped over it, but I do want to mention, in case I did skip over it, that there are some more heavyweight functions to be aware of. Just to be aware of as a developer as you're using the API. So while everything is done in parallel across the cluster, there are some that I think, in MapReduce it's true as well. So this isn't anything new. But things like a group by or a reduce by, those types of operations or sorts, those are going to be more intensive than some of the other ones. All right, into Cassandra. This is very, very much the drive-by version of Cassandra because I really want to cover this quickly, and for any of you that aren't that familiar with Cassandra yet, so that we can just jump right into talking about the Spark Cassandra connector and then how to integrate everything. And I think I just have maybe 2 slides for you guys. Okay, so 10 things about Cassandra to know. First, there's no concept of master and read replicas. At DataStax, we test 1,000 node clusters every day for days at a time. Backups can take less than 1 second. Adding a column to a table will take the same time with 1 row of data or a billion. New nodes, oh, sorry, hold on, I'm having technical difficulties. New nodes automatically add themselves to the cluster. The DataStax drivers discover new nodes automatically. You'll never have to shard again. Every write is durable. Replicating across multiple data centers allows you to provide lower latency. That's just one of the many things built into Cassandra. And that allows you to survive regional outages. If a Cassandra node fails or gets overloaded during a read, queries are retried to a different node. So a node down doesn't equal a database down. And a database down, or a data center down does not equal a database down, basically. So you can lose over half of your cluster and still be online with, no differences. So it's pretty much the perfect platform for mission-critical data. And from what we understand, the largest production deployment has over 75,000 nodes. So it's been used extensively in very, very large mission-critical operations. It's very, very easy to use. I know that before, I think maybe a year ago or earlier, there weren't the tools that are available now to work with Cassandra that are very, very nice. I think I had looked at the Netflix API, which is great. It has a lot of really nice functionalities, but with the change to CQL 3, everything became much easier. So the syntax for CQL, they just didn't want to name it SQL, but it's pretty much the same. I mean, if you've done SQL in the past, looking at the CQL syntax there, it looks pretty much the same. The only things that might be different, well, there are a few things, but one thing to remember is that the Cassandra data model, because of it being a highly distributed, highly scalable, very fault-tolerant database, it does have some other features added to it that allow you to design things differently. And when you're working with Cassandra, you really want to pay attention to your data model, and that is because the way you design your data model can really affect how fast Cassandra is able to perform for you. And we have one of our resident masters on that, Patrick McFadden, but he wasn't able to join us today. It's very friendly to programmers using the API. You can see like the insert into, that's just how we would do our regular SQL syntax. So let's dive into working with the Spark Cassandra connector. So we have direct integration with Cassandra now with usage of the Spark Cassandra connector and Spark. We can co-locate a Spark node with Cassandra nodes in the Spark and Cassandra clusters for the best kind of performance. So we really do advocate co-locating those nodes. That way you're going to have the fastest operations that you can. So in this diagram, we're looking at, basically we're talking about the being aware of data locality for speed. Cassandra supports server-side filters, so all the where clause and select, none of that is going to be happening on your driver side or in your Spark applications. That's all happening on the server side. And that all is happening is done for you by the Spark Cassandra connector. So we're reading from Cassandra to Spark and then doing computations, and then we can write back to Cassandra all in one functional stream. And I have some samples showing you about how to do that, very, very easy. Also, we can stream information from Kafka, run it through Spark computations, and write that data out to Cassandra very easily. All Cassandra types are supported and converted into Scala types for you by the connector. You can use the connector with either Scala or Java, but it's written in Scala. We have a separate Java API. It's currently compatible with Spark 1.1.0, but we're almost ready to release the 1.2.0 compatible. And when Spark releases 1.2.1, we're going to be soon after that ready to release the 1.2.1. Also, it supports virtual nodes. That is the GitHub repo for the Spark Cassandra connector. We also have, besides the code itself, we have a lot of demos, and also in the IT tests, for example, if you want to look at implementation using Spark SQL, for example, with using Spark SQL syntax with Cassandra, we support that, and you can look at, for example, some of the IT tests. It's very, very, very conclusive, I think, with how you can do it. And also our documentation is in there. So again, server-side filters, all the where clauses. It supports cross-table operations. So with the Spark Cassandra connector and Spark SQL integrated now, you can start to do joins, which you couldn't do before with no SQL databases, unions, things like that. It supports data locality awareness, so you get the benefit of speed. Data transformation, aggregation, that all becomes very, very easy to work between Spark and Cassandra. We just started to support user-defined types. And a brief slide on the Cassandra data model. So here, for example, if you want to think about this two different ways, here's a sample table in Cassandra. That username might be our row and then our partitioning, but also that's our row key at the top and our primary key, and then there are our data columns. One thing to note, I don't know if this is the right place to mention it, but I definitely wanted to mention it before I forget, is that what we do in the connector is we have a custom load balancing policy. Basically, the connector is telling Spark where the partitions are located because Cassandra is innately aware of all of the nodes in the cluster. We never are selecting nodes from other DCs. It's always going to be some kind of nearest neighbor or the Spark node on one host is going to be talking with the Cassandra node on the same host, so that all the data is being operated on much more quickly. And some of the use cases, the thing to consider as you read through this slide, with Cassandra, this is something that I found anyway, with Cassandra you do things a little bit differently. You want to start with the data itself instead of sort of working back from the use cases and then modeling your data. You start with the data and then you want to think about what are the queries that I actually need to make. And then within that context of multiple data centers and clusters, the speed that you need, scalability and replication, you would do that very differently versus creating a data model first, for example, with standard databases. And if your queries are around sampling by window, for example, for time series specifically, you really want to be using Spark streaming. And time series work is something that Cassandra really is built for. So if there are, like for particular date time instances or aggregations that you want to use, it's very easy versus, working with sliding window. Spark streaming can help you operate, do all this work very, very easily. I have one quick slide specifically on data locality to sort of show you with that diagram how we're, just advocating co-locating all of the nodes. This is really primarily for speed. And again, we use the local node first load balancing policy. It decides what node will become the coordinator for the given mutation or read. The Cassandra RDB in the connector is going to make a list of the splits, and the splits, that's something that comes from Spark streaming, or Spark rather. Every split is then stored on at least one Cassandra node, and then Spark is going to be asking for the host names of splits by calling get preferred locations in its internal API, and this is all handled by the connector on the Cassandra RDB itself. To actually start using the connector, this is for an SBT app-based application. This is how you would add it to your project. Okay, and a bit more about actually using the API. Okay, so here's a really basic declaration. So we're, in this sample, there's many things that you can do with that Cassandra table call, and this is from the Spark connector. So I can leverage my already created Spark context, that's my SB, and call Cassandra table. Out of the box, it's going to return basically a sequence of Cassandra row objects, but you can very easily, as I'm going to show you here, change that data type, and it's very easy to do that conversion. It's sort of out of the box for you. But all I need to do is specify my key space, my table, and then again, this is all happening server side, select and where clauses. Very, very easy to do that work working with Cassandra, and then I get my table of table object holding my Cassandra row object. So here, what I'm doing, I have my Spark conf. I'm showing you just a little bit more of some of the settings that you can pass into the Spark conf object itself. But now, a few lines down there, I'm doing spark.cassandra.connection.host, and that's where I'm going to pass in. You can do either a string or you can do a comma-separated list of hosts that you want it to use as contact points, initial contact points. And from there, it understands where the cluster is in the connector. And then I create my streaming context. I'm going to set my batch interval to 30 seconds. And as we saw before, I'm going to leverage the Kafka streaming API from Spark, create my stream very simply. I'm going to do a basic word count. And now I'm going to save that off to Cassandra to my particular key space and table. So that's a pretty slick integration. It's very, very clean, very easy to use. And then again, start the streaming context, await termination. Here's a very, very basic Spark streaming Twitter sample integrating with Cassandra too. Pretty much the same setup that we've been showing before, but in this case, I'm using the Twitter utils class, create stream from the Twitter streaming API in Spark streaming, or sorry, in Spark repo. Actually, I think that's a mistake on my slide. I was trying to update something. I have two Twitter utils create stream. There's really only supposed to be one. Sorry about that. And then from that stream, I'm going to split that, flat map that through lowercase everything, and with that filter function. And this is all, collections you're working with using the core Spark API, that filter function. However, the count by value and window, I'm pretty sure that's Spark streaming with, yeah. So I can set up my my intervals there for my windows. So I'm just going to filter by the topics that I want to look for in these tweets. And then I want to transform each of the RDBs by a particular time that I want to look at. I'm mapping each of those together and then forming those new RDBs in the D stream and saving all that information off to Cassandra. And that's doing that iteratively. It's not sort of doing a batch saved to Cassandra. Let's see, how much time do we have? Okay, a few more items to show you how cool the Spark Cassandra connector is. So for paging reads using Cassandra table,
hi Helena. How many more slides do you have to go through right now?
Well, I have 20, but I could cut that down. I really hope to just show some code, so I could cut some out.
Yeah, let's go 5 more minutes. We're over time right now. So to everyone, we will not have Q&A today, but we will send a notification when the archive is available with Helena's blog post that will address, the bulk of the questions that are being asked today. So apologies for that. And please stay on for a few more minutes. And Helena, maybe you can just go through the slides quickly and then wrap up.
Yeah, sorry about that, you guys. I was not watching the time. What I'd like to do actually is move from the slides and just take a few minutes since we're over time, just maybe 3 minutes if you can hang in. I wanted to show you some application code, but the nice thing about this is that it's on GitHub, so you can look at it yourself when you have some time. I'm going to share my desktop really quickly. Okay, so in this repo, let me show you really quick where it is. I'm hoping you guys can see that. Is it big enough? All right, I haven't heard it's not. So if you want to check out this, it's github.com/killerweather, K-I-L-L-R. In this repo, it's sort of a sample application for integrating with Spark, Spark Streaming, Cassandra, and Kafka, Akka, all in an API. And there's a client application in here. There's scripts to set up Cassandra for you, the schema and everything. There's a, the server-side application. There's a lot of different things. There's one of the client applications uses Akka Stream, so you can see some really nice stuff in here. And just really quickly, I wanted to show you because let's see, so 2 minutes. This is an example of just an object that we're going to be loading the application up with. This is stuff that we saw. This is using an embedded Kafka that's in the embedded module of the Spark Cassandra connector, so you can use this yourself as an artifact for quick prototyping. I'm setting up my Spark context, my streaming context. Here I'm going to start up my Akka actor system, and I'm creating this one actor supervisor called my node guardian. And then from that, I'm going to create all of my child actors. I wanted to just show you what some of these actors look like so you can see some of the code in action. Let me show you just really quickly the Kafka one. So this is sort of putting it all together, tying the room together kind of thing. I'm creating my Kafka stream here. See if I can make that any bigger. Take my Kafka stream. I'm going to store off, like I showed you, my raw data to Cassandra right away. There's a lot of documentation in this project, so you can read through it if you're interested. I'm going to do another function on my stream, and then this is going to tell the guardian, the supervisor, the primary supervisor in my application, that all of the outputs for Spark streaming have been declared, and now we can start the Spark streaming context. That's just a little strategy that I have. One of the, like this temperature actor, for example, and if you're not using Akka, you can just think of how you would do this in a regular class. It's really no different. This is just in a asynchronous event-driven environment. I have a class, here it's an actor. I have some basic functionality like this aggregation actor, because you'll see in this project there are several different components doing kind of standard aggregation work, and they do that based on when they get triggered. So when they get receive these events. So here what I'm doing is trying to do some daily aggregation on some data. I call, here's my Spark context. This is just working with core Spark, not Spark streaming. I call to the connector Cassandra table, and I'm going to be returning this aggregated data as a sequence of doubles. And you don't have to do any casting or anything weird at all. You just declare the type here, and the connector is going to do all of the transformations for you. But I just declare my key space, my raw table, our table name. I do my select statement, my where, all happening on the server. And then I can call collect async. So again, remember this is returning a future, Scala future. And with the Akka API, I can first convert that to my kids class, and then pipe that to the actual requester for the data. So here I'm doing an aggregation for high-low temperature, standard stuff like that. And I really think that that's it, because I don't want to hold anyone else up, but you can look through this code anytime. So again, let me just switch really quickly to my final slide. I'm going to upload this to SlideShare. It has a bunch of resources for you for all the different projects that I talked about. It also, this right here, the last one at the bottom is our connector user mailing list. So you can also ask us questions there. Be aware of Spark Summit and Spark Summit East that happen every year. I wanted to also mention shout out for Cassandra Summit, happens every year. And if you wanted to follow me on Twitter, that's my Twitter user. I'm going to tweet the follow-up blog post when it's published and what the URL is. And I'm also going to be tweeting how to download all the slides since we had to skip through a lot of them. And I apologize for this being so verbose, but I hope that everyone was able to get something out of it and that you enjoy working with everything. So thanks, everyone.
Great. Thank you so much, Helena. And we will be saving all the questions that got submitted. And to Helena's point, she'll be writing a blog on it, and we'll make sure to follow up with everyone. So thanks again, Helena, and have a great day.
Thanks. Yeah, everyone's questions will be answered. So thanks for those. Bye.